In this Arduino tutorial, what we're going to do is measure a voltage from 10 volts down to 0. Now, what you've got to remember about the Arduino is it can only take 5 volts. If you try and input anything on its pins above 5 volts, you're going to damage it. This will work with a 9-volt battery and below, but if you try and wire this up and use a 12-volt battery, you'll damage your Arduino straight away. I'm just going to use a voltage divider here with 2 resistors, and I'm going to cut the voltage in half. Now, the way you do that, of course, is you just pick your 2 divider resistors to be equal, and the easiest way to do this is just set them to 1000 ohms each. So that's what I'm going to do in the example. I just set them to 1000 ohms each, but I'm going to explain how it works anyway so you can understand. So what we've got here is, this is how you wire the Arduino up, right? So you've got your analog section of pins here. Now what you'll do is you'll wire up on the breadboard a resistor, 1000 ohm resistor there, and underneath in series another 1000 ohm resistor, and then the top of that will be connected up to your battery. Don't connect your battery up until you've got everything working. You wire up your 2 resistors in series like this, and the bottom resistor, we'll call that R2, because what we're going to be doing is we're going to be looking at the voltage drop across R2. That's between the center between them both and the earth, because we're going to connect the other side of R2 to ground. So on the Arduino you'll find that there's 2 ground pins, so just connect the bottom of R2 to one of those ground pins. The other side of R2 will go to the bottom of R1, and the other side of R1, that's where we'll be measuring our voltage from our battery to see if the battery's gone flat or what the voltage is of the battery, and it will display it out on the screen. So we're going to connect this up using the serial connection, so that we can actually, whilst we're connected to the Arduino with our computer, we can actually see the output, and then when we're happy it's all working, we could change that to say LEDs or something. But you can do that yourself afterwards, because you know how to set up an LED from an output pin. So you could easily set up an LED to go red or orange or green depending on what the voltages are. So, but with this circuit you'll be able to do that very easily. So I'll just carry on explaining this. So yeah, so then you've got the center between the 2. That's where you'll want to tap off there, and you'll tap that off into the analog input pin, because what we're going to be doing is we're going to use the Arduino to measure the voltage drop between what I've put here, V0 and ground. So we're measuring the voltage drop across R2. Now if you remember from the voltage divider, what we're actually doing here is the amount of energy per coulomb that drops across R2, in other words the amount of voltage. So when I say energy per coulomb, joules per coulomb, we mean voltage, yeah? So the amount of voltage or energy per coulomb that drops across R2 is proportional to the amount of resistance in the actual series circuit. So it's like R2, so if you imagine they're both 1000, that's going to be, the total resistance is 2000, so it's going to be 1000 over 2000, so it's a half. So you will, whatever the voltage Vs is, you're going to get half the voltage at V0, and that's the formula for it here, just to remind you. So you got R2 over R1 at R2, then 1000 above 1000 add 1000, that's 1000 above 2000. Well, all the zeros cancel, and that's a half. So if Vs is 10, you're going to get V0 is 5. So that's why I'm saying you mustn't use this for anything more than 10 volts, because the Arduino can handle 5 volts, but it can't handle anything above 5 volts. The other important thing, if you do, when you do this, make sure you measure both your resistance with an ohm meter, because if you find that R2 is slightly bigger than R1, then you're going to get more voltage drop, and it's going to change that form. Just to give you an example, say R2 was, not that it would be this much different, but let's just assume it is. Let's just say that R2 is 1500 and R1 is 1000, so it's 1.5k ohms and 1k. 1.5 on R2, let's see what happens. So 1.5 over 2.5, well, if you plug that into your calculator, you're going to get 0.6. Well, 0.6 of 10 is 6 volts. So then you've damaged your Arduino, because we've made that 1.5 and that one. Now, if you do find that your 2 resistors that you choose, one happens to be slightly bigger than the other, then the simple thing to safeguard your Arduino is to always put the smaller resistor as R2. So if that's 1000, that's say 900 ohms. Don't put your 1000 here, put your 900 ohms here, Not that they would be that much different, but wherever they are, measure them anyway, because you don't even want it slightly above 5 volts. Just measure them, whatever ones, because they won't always be the same, they'll all be slightly different. So whatever the smaller one is, just make sure it's R2, then there's absolutely no chance you can damage this thing, because it's under 5 volts. In fact, the Arduino, they state it as 5 volts, but it's something like 5.5 or something, but, you know, it's better to stick with 5, assume that it's 5, yeah, don't assume that it's 5.5, just assume that it's 5, yeah. So that'll make sure that it's safe. So yeah, so what you'll end up now then is obviously we can measure that with an ohm meter. So if we drop an ohm meter across there, it's a standard voltage divider, we'll find that that's 5 volts. If this is 1000, that's 1000, that's 10, then it'd be 5 volts. Now if that's 5 volts here, then what that's going to be 2.5 volts. So we'll be able to measure any voltage between 10 down to sort of 0. We'll be able to get the half value of it here. So, but what we want to do is we want to find what Vs is. So the easy way to do that is the Arduino is going to know what V0 is, because it's going to read it in on its input. So all we have to do then is, the only unknown we've got is Vs. As far as Arduino is concerned, it doesn't know what Vs is unless we rearrange the equation. So that's easy enough. All we need to do is get it in terms of Vs. Get this equation here, this divider equation, in terms of Vs. So if you know any algebra, it's easily done. You just multiply it out by R1 at R2, you get that on that side, then you divide by R2. So you end up with this. So if you don't know the algebra, just take it from me that if you get that in terms of Vs, you end up with this equation here, okay? So now this equation basically will give you what Vs is. Let's just test it out with some values. If I say that R2 is, we're going to say, yeah, we're going to let that be 1000. So we've got 1000 there, 1000 there. So that's 2000 on the top and 1000 on the bottom. The zeros are all going to cancel and you end up with 2. So you end up with this equation here, 2 V0. Well, we know that if V0 was 5, so if this measures 5 volts, if this measured V0 to be 5 volts, then 2 times 5 is 10. We know what Vs is. And that's what we'll print out on the screen. So when we go 2 times V0, and this has measured it as 5 volts, we're going to get 10 volts coming out on our display, on our computer display. And that's what we're going to do in the code when I show it in a minute. Now, that's basically how it works. But there is a small consideration. The Arduino doesn't actually pick things up in voltages. It actually converts voltages into a digital number between 0 and 1023. Now the number 1023 is designated to be equivalent to the 5 volts. So if you put 5 volts on an analog input on the Arduino, if you put 5 volts on there, the analog will see that as 1023. So it's divided the 5 up into 1023 parts. If you saw on the analog input, say for example 511, which is half of 1023, that would be equivalent of 2.5 volts. You know, 5 volts, half of 5 volts is 2.5 volts. So we've got to do a little bit of adjustment in the code to allow for that. So this is how we do it. We just do a division here, 5 divided by 1023. That's what's going to give us the actual voltage. So if we divide the 5 volts by 1023, which is what this Arduino sees 5 volts as in terms of converting it to a digital number, then we're going to get this number, which is 0.0049 volts. Now that is the equivalent of one of those divisions. So if we took one of the 1023, in other words, if that came in as 1, it would be equivalent of 0.0049. So if you multiplied 0.049 by 1023, what are you going to get? You're going to get 5 volts, yeah? So that's what it is. So every division from 0 to 1023, the Arduino sees is equivalent to 0.0049. Now if we know that, then it's easy to get back to this equation here, which is Vs equals 2 times V0. All we've got to do is remember that every division is 0.0049 and multiply it by 1023, whatever it is. So if it's 511, it would be 0.0049 times 511. Remember, 511 is half of 1023, and that would be equivalent to 2.5 volts. That's how the code is going to read in the digital input. It'll be a number between 0 and 1023 and convert it to the voltage we want. And then all it's going to do is going to multiply that by 2, and that will give us the source voltage. So if we put any voltage here between 10 and 0, we're going to be able to read it out and display it to the screen. Doesn't matter what the voltage is. It's not going to be an accurate voltage meter, but it'll get it accurate between, maybe a hundredth of a volt, which is good enough for most practical purposes. Then you can imagine you can do things like have a red light if it goes over 5 volts, have a green light if it drops below 4.5, and then have an orange light if it's in between or something. So you could you could actually measure a piece of equipment and you didn't want it to drop below, say, 10 volts. You wanted a warning bell or a speaker to go off, then the Arduino could do that. It could activate a speaker. I'm just going to show you the code that actually will print it to the screen, but instead of printing to the screen, like I say, you could activate a speaker, activate an LED, do anything like that. So we'll just go through that now, and I'll show you that as the code. So that's basically what the code's got to do. It's got to handle this special condition here. Here's the Arduino code. If you want to take a screenshot of that, then you can just copy this and adapt it to whatever you need. I'm showing the serial class here. Now this is very useful. It means that the Arduino board can write back to this computer through this software, and we can see the output that the Arduino is seeing. So that's very useful, and we get the output by, within the code, actually using this command, println, and whatever we put in println will be displayed on our serial monitor. And the serial monitor you can get by clicking this button here. You see, if I hold over, it says serial monitor. Now that can only work if you've got your USB cable connected into your Arduino. If you pull your USB cable, then obviously you're not going to get anything on the serial because it's not connected at that point. This is useful for debugging, really. Once you've got everything working and you know that the values are right, then you can replace that with, say, maybe bracketing 2 voltage values, one above 5 volt, one below 4.5. If they're outside that range, you might want to show a red LED, or if it's above 5, you might want to show a red one. If it's below 4.5, you might want to show a green one. If it's okay in the middle, you might want to show an orange one, which is where you want it to be, or something. So yeah, you can basically take a battery and just check that it's gone flat, and if it's gone flat, make this thing buzz a noise or make a noise or something, or flash a light. So I mean, there's all sorts of ways you could use this very simple meter program, but I'll just go through how it works really now. So this is it. It's just this screenfall here. So we've set the two. So what we have to do is like emulate what the resistors we've used. Remember I said that if we keep both the resistors the same value, then we're going to get half the voltage at the analog input V0. Don't pick 1 ohm and 1 ohm, otherwise they'll just catch fire because there'll be too much current running through. Pick 1000 and 1000. You're only using up a small amount of current and a small amount, a few milliwatts or something. This next argument is the battery pin, and that's the analog input, and we're specifying what analog input it is, and it's pin 0. So that's battery pin 0. Voltage ref. Well, voltage ref for the Arduino board, it can only take 5 volts. Now there are other Arduino boards that run off 3.3 volt. They use less power. Now those ones, if you're running a 3.3 volt Arduino, then you've got to change that to 3.3. You don't want to rerunning that with 5 then. That means your range from 0 to 1023 will be with reference to 3.3 volts and not as mine is now, 5 volts. But that's only if you've got a 3.3 volt Arduino board. So that's the only thing you've got to change. So you haven't got to change anything else because I haven't hard-coded anything in here. That's why you've got all of these things that says volt ref down here to make sure that we don't hard-code anything in. So yeah, so then the setup. Now inside this setup, all we have to put in here is just specify that we're using a serial monitor. And if we print anything from the actual Arduino, which is what we're doing here, so you can see serial.println, we're going to print anything we like. That's going to come back to this computer and into this software. And we've got a serial monitor here. If I just highlight that, you'll see a serial. When I click that, you'll get a screen come up, and the output from the Arduino will appear in that screen. I'll show you in a second. So let's just run through the code now. So yeah, so we pick up the value on the analog input pin, pin 0. Then all we do is we use the volt ref. In this case, it's 5 divided by 1023. That again, remember, that gives us the amount of voltage per one of those divisions. So then we multiply that value by the actual value that's been input. So that could be like 511, you know, half of 1023. With the voltage value then, of course, that will give us the half voltage of the battery that we're measuring. If we see 4.5, then we know that that battery is 9 volt. And we can just take that 4.5 volt, if we've measured it 4.5, and just multiply it by 2. Well, you know, 1,000 out of 1,000 divided by 1,000, that's simply number 2. 2 times volt val, that will give us the 9 volts. Now the reason I've specified R1, R2 up here and done this, you can actually adapt this program to do things like, if you wanted to measure a 24 volt battery, then you can play around with the voltage divider. I'll let you do this at your own risk, but it's easy enough if you understand how the voltage divider works, and you can just adjust those so that you've got like 1/3, so that 1/3, if it's 1/3 coming in on the analog input, then you've got 3 times that, so then you can go up to 24 or 50 volts or anything you like. You just got to make sure that when you do the voltage divider calculation, you make sure that the voltage dropped across R2 is always 5 or below voltage. You can do that with your own meter before you even start. So if you want to make a circuit that's going to measure a 24 volt battery, don't connect it to the Arduino first. Just build your voltage divider and just put your own meter across that R2 to ground and just check that it is under 5 volts or 5 volts when you've got 24 volts on it, on the top, on the VS part. So then you can measure any voltage with this, but I've just used it for 10 volts because I mean most of the time for the stuff I do it's going to be 9 volts, 10 volts, and you know, if you're just mucking around with the Arduinos, you're never going to be going above 5 volts anyway, really. So that's the circuit. So what we'll do is I've just got a battery on there now just to test this out. That's a battery. I've got 2 1.5 volt batteries in a little holder. Now when they're fully charged that's 3 volts, but they're pretty flat now, so let's see what they measure, and then I'm going to switch this off and then go back to the normal camera and we'll see what the ohm meter says for that battery, and you can see how I can then maybe do another battery as well. So let's just run over and click up the serial port now. Now that if we run the serial port, I've already connected the battery and you can see it's showing 2.47 volts. So that battery I've got connected, it's telling me that the battery, that holder, is 2.47 volts. So let's come out of this now and we'll go into the normal camera and just check that with the ohm meter so you can see if that's correct or not. So basically that's the code, that's the whole thing. That's all you need if you want to adapt this yourself. You don't need anything else. And let's just go and have a quick look and see what those battery, I'll choose a couple of other batteries as well. Oh, so here's the circuit. You see the Arduino board, and I've plugged in the 2 resistors there, so that's the voltage divider with the 2 resistors, and this is the battery that we're checking. So you can see I've got 2 AA batteries in there. So you saw on the screen there it's 2.47 volts. Let's have a look exactly and see how much that actually is. So I've got my voltmeter there, and we'll just run that over the top and just see what that voltage is. So we'll put it onto voltage settings. There you go. It's actually spot on. That says 2.47. I don't know if you can see that. Let's try another battery, and what I'll do is I'll point the camera at the computer screen this time to save a bit of time. As long as we're under 10 volts, we're okay. So let's try this battery. I've got 6 end-loop batteries in there, AA. Again, they're pretty flat, so let's see what they give us. That's 7.82 volts. Now I'm going to plug that one in to Arduino now, so that's going to be reading this one now. So the serial port will just show whatever it's reading on this. So let's plug that in and see what our code says. So I'm going to move this over now and point it to the monitor. So let's go over there. Oh, if I just move that over so you can see it, I'm running this over here. So let's just move that over. That's 7.89 volts. So it's slightly out. It's reading slightly over what it is. But it's close enough, you know. I mean, for all practical purposes, that's probably all you'll ever need most of the time. You know, if the battery's flat, it's generally flat when it's 1.5 volts below. So, you know, That's all you need. That's the only accuracy you really need. That's it really. That's how it works. I'm gonna do something a little bit different on the next tutorial. I'm going to be playing some notes to show you how you can put notes together and make a sort of tune with the next one. So yeah, please watch the next one. Like and subscribe if you've enjoyed these tutorials, and I'll see you on the next one.